And after looking at, comparing the generic Medusa versus the specialized Medusa, we also want to look at how this optimizations of the new inference engine translate to the real world latency across different providers. And here I want to present some benchmarks regarding, comparing our new inference engine versus some of the other inference providers in the market. So here we actually benchmark a real world customer use case on our Inference Engine 2.0, on Fireworks and also VLM. So the use case is preference matching explanation. You can imagine examples like the input of the model being, for example, a job match to a candidate, and the output of the model should explain why the job is a good fit for this candidate profile, or why the candidate is a good fit for the job. Or in another example, you can imagine, for example, in matchmaking services, the input being, okay, two profiles being matched, and you expect the model to generate an explanation of why the two profiles are good matches, right? So things like this. This is called preference matching explanation. And then we also benchmark on a token distribution profile of around 350 tokens input and 50 tokens output. And we benchmark on one single H100. And for all the latency benchmarks we show in the next slide, all the numbers are server processing time without considering any network latency. And most importantly, as Magdi mentioned previously, one of the most important feature we enable in the new inference engine is called trunk preview, which lets the model to start working on your requests much faster by breaking your input into smaller chunks and feeding them into the model piece by piece instead of all at once, which keeps your GPU fully utilized during inference time. So with all these assumptions, we can actually look at the real benchmarks that we got from this exercise. So this diagram shows the P95 latency across a variety range of QPS requests per second. So ranging from a single request to 5 to 10 to 15 and all the way to 20, because we also want to test how the deployment performs when it scales up to the real production traffic workload, when the traffic gets overloaded, right? So that's why we benchmark at different QPS levels. And we compare 3 different inference providers. So the Predibase-based model, the Predibase TurboLoRA model variant, Fireworks-based model, and also BLM-based model. And as you can see in this chart, across all QPS levels, for Predibase, the blue bars and the red bars, we consistently delivers the lowest latency numbers, and we remain pretty competitive even at higher QPS levels, which means our inference engine scales pretty well when the workload becomes heavier. And for Fireworks, which is the yellow bar, Fireworks-based model actually remains pretty competitive at lower QPS, but it shows much higher latency under higher load, which suggests that it is less efficient scaling up. And for Fireworks, I also want to mention for the Fireworks benchmarks were generated on a self-serve deployment that I spun up on the Fireworks platform using all the defaults. So I did not do any manual tracking to try to optimize the deployment. So when you look at these numbers, this is one of the consideration you need to take into. And then lastly, for VLM, so as many of you already know, VLM is one of the most popular open source inference engine in the market. And we also spun up a deployment on RunPod's serverless GPU platform for VLM. So this is actually VLM deployment served on RunPod. And as you can see, so the green bars numbers represent VLM latency. And for VLM, you can see even with VLM and RunPod's GPU support and availability, it turned out to be underperforming across the board when I use the self-serve deployment. So this comes to like one of the most common questions we get asked by customers, right? So a lot of customers compare us to, open source inference platform like VLM and ask like, okay, VLM is open source and GPU resources are widely available. So what are the key advantages of using a fully managed inference platform like Predibase, right? So during this exercise, I hope, and also based on these numbers, I hope the key takeaway is that the user experience in general, by self-serving the deployment through VLM on RunPod, and also all the benchmarks tell us that building a reliable and scalable inference setup for optimizing the performance can still be very, very challenging. So you have to, since it's open source, it's not fully managed, it's user managed. So you have to deal with a lot of challenges like model compatibility, performance tuning. You have to do optimizations yourself, and you have to figure out a variety of operations burdens, things like infrastructure, configuration, observability, all the features that Magdi just talked about. We take care of all of this for you. Whereas if you use open source inference platform like VLM, you have to take care of this all by yourself. And also you have to deal with, all the API integration complexities across different platforms, because for this exercise, I use RunPod as our GPU renter. And this overall, this results reinforce that Predibase's end-to-end optimization stack, especially when it combines with TurboLoRA, enables both high throughput and low latency, making it a very, very strong choice and platform for any production ready inference workloads and use cases.